we're going to look at the product of two binomials. We have a product of two binomials. Why is it a product? Well, we've got two things that are multiplied together, right? And that's what a product is. And a binomial, well, this is a binomial because it's got two terms. This is a binomial because it's got two terms. And we're multiplying them together. So we've got a product of two binomials. Okay, how do we do it? The important thing is it's this whole bracket is multiplied by this whole bracket. So we must make sure everything in here multiplies with everything in there. And the best way to do that is to actually put in arrows before you start. So we need this 2x to multiply with everything in the second bracket. So it needs to multiply with the 3x, but it also needs to multiply with the minus 5. And then we go on to the other term, which is 4, and it needs to multiply with everything in the second bracket. So it needs to multiply with the 3x, but also with the minus 5. Now we can go ahead and do that multiplying. 2x times 3x, starting with the red ones, is going to give me 6x squared. Then I go on to the greens. That's going to be 2x times minus 5, which is minus 10x. Then I go on to the whites, 4 times 3x, which is 12x. And then I go on to the blue, minus 5 times 4 is minus 20. And now I just sort this out. 6x squared doesn't have any term to go with. 12x and minus 10x are like terms, so I'm going to combine them to get 2x. And that is my answer. Some people like to use this little acronym FOIL to remember to multiply everything. What FOIL stands for is first, so you multiply the first two terms together, then outsides, the outside terms together, I, the inside terms together, and L, the last terms together. If that helps you, use it. I often just find as long as I put the arrows in that show me everything, this must multiply with everything there, and then this must multiply with everything there, I don't forget terms. One more quick example. This one I just want to point out an important thing which we've discussed before. When you notice that you're going to have to, when you've got a negative, put some bright sign around it so that you don't forget it. I'll show you why. We're going to multiply out in the same way, so I'm first going to put all my arrows in as before. No problem with the first. Let's do the reds. 2x times 3x, which is 6x squared. 6x squared. Then let's do the outers, which is the green, right? 2x multiplied by negative 5, and that's going to give me negative 10x. Now we're going to go and multiply this thing here with everything in the second bracket. It is very important, which is why I've put that big circle around it, to remember it's a negative 4 that is multiplying with everything in the second bracket. So when we do the whites, we're going to have negative 4 multiplied by 3x, and that is going to give me negative 12x. And then I'm going to do the blues, which is going to be negative 4 multiplied by negative 5, and that is going to give me positive 20. And then again, I sort it out as before, combining our like terms. Negative 10x subtract 12x is going to give me negative 22x, and then plus 20. Let's just do a little bit more on the product of two binomials. I just want to draw your attention to one little pattern, and we'll come back to these many times over in the next while. But if you just have x and a number in your binomials, mostly you're going to end up with 3 terms in your final product. So if we have a look here, right, just again, how do we do this? Make sure we multiply everything in first bracket with everything in second bracket. X times x is x squared. Then I go to x times minus 2, which is minus 2x. Then I do 3 times x, and then I do 3 times minus 2, which is minus 6. These two are like terms, so I'm going to have x squared plus x minus 6. Here's the interesting one. Again, nothing different to start, just make sure I multiply everything with everything. So x times x is x squared, and then x times minus 3 is minus 3x, then plus 3x Plus 3 times x is plus 3x, and then 3 times minus 3 is minus 9. Here's the interesting bit. There are your like terms, but when you add together 3x and minus 3x, right, they just cancel each other out, and so you just end up with 0 for that. And so you get x squared minus 9, and in this case, you only have 2 terms. And this is the special case of when you have, it would be similar if you had x plus 4, x minus 4, or x plus 5, x minus 5, or in fact x plus a half, x minus a half. And I hope when you were trying out the exercises, you weren't fooled into making the mistake that so many people do when faced with something like this, and just say x squared plus 3 squared is the answer, which is x squared plus 9, because that is totally and completely wrong. Because what does x plus 3 squared mean? It's x plus 3 multiplied by x plus 3, and so we need to do it in the way that we always do, and we'll get x squared plus 3x plus another 3x plus 9, which is going to give me x squared plus 6x plus 9. So just watch it, right? Do not make this mistake. It's very easy to fall into that trap. Now that you've got good at multiplying out, you can tackle a monster like this one. Now before you tackle it, please remember my suggestion, where you've got minus signs, just take note of them, because it's so easy to go wrong with them. And in particular, this minus sign here goes with everything that comes after it here. So I would actually say to you, put this in brackets and deal with it. And then once you've dealt with what's inside those brackets, that minus sign will then have to be brought in. Okay. Try it, see what you can do, and we'll go over it afterwards. Pause the video now and try. All right, so hopefully first bit was quite easy, right? You just need to multiply in. Minus 5x times 2x is minus 10x squared. Minus 5x times minus 3 gives me plus 15x. Now, taking my own advice, I am going to just deal with everything in those brackets first. So x times x times minus 4, and that. Normal multiplying out, making sure I multiply everything in first bracket with everything in second bracket. So I get x squared minus 4x minus 2x plus 8. I then just combine my like terms here, and I'm going to get x squared minus 6x plus 8. Now I'm going to deal with that minus sign, because that minus sign has to go with absolutely everything that's in here. So I'm going to have that it is going to be minus x squared. Then the minus goes with this minus. Minus times minus is plus 6x. Minus with this 8, minus 8. And my very last step is then to combine like terms again. I've got a like term there and there. I've got a like term there and there. And so what I'm going to get is minus 11x squared. 15x and 6x is 21x. And then that little old minus 8 at the end. Let's have a look at the exponent law for division. Let's do a quick recap of the division rule. So, a to the m divided by a to the n. Remember, we can always rewrite division as in a fraction form, so a to the m over a to the n, same thing. And our rule tells us that if we are dividing the numbers, we need to subtract the exponents. So, for example, if I had p to the power of 5 divided by p to the power of 3, my rule tells me that I just say 5 minus 3, and I get p squared. So the rule is a very simple one. When you're dividing, you simply subtract the exponents. But let's just remind ourselves where that rule comes from, because we shouldn't just have rules that are mysteries to us. They should make sense. So let's have a look at where this rule comes from. If we simply write out what the exponents mean, we can see where the rule originates from. P to the 5 is just 5 p's multiplied together. P cubed is just 3 p's multiplied together. Now you can see that these 3 p's at the bottom are going to take out 3 of the p's from the top. And so what are you going to be left with? Well, you've taken 3p's from the top, so what you're going to be left with is 5 minus 3 at the top, which is 2. So you can see very easily the rule is not some mystery. It makes complete sense that when you're dividing the numbers, you subtract the exponents. Right, let's have a look at simplifying something like this. We just work one step at a time, so we're going to first simplify these numbers here. So we're going to do 8 divided by 4. Now these are plain old simple numbers, they're not exponents, so we're going back to what you did at primary school. 8 divided by 4 just gives you 2 as the answer. Next, you're going to move on to the x's. Now here you are dealing with exponents. So you've got x to the power of 8 over x to the power of 4. You're going to apply your exponent rule for division, which is x to the 8 minus 4. And then you're going to move on to your y's, and with your y's, you've got y cubed over y. Remember that this y just means y to the power of 1. So you're going to use your rule again, which is going to be y to the 3 minus 1, and you'll get your answer 2x to the 4 y squared. Let's remind ourselves about what negative exponents mean. I'm going to look at a cubed divided by a to the 5 in 2 different ways. In the first way, I'm going to go right back to the basics and write out what a cubed is, a times a times a, and what a to the 5 is, a times a times a times a times a. I'm then going to notice that I can cancel like that, and then what I will be left with, at the top I've just got 1, and at the bottom I've got a times a, which is a squared. Now I'm going to look at a cubed over a to 5 in a different way, and that is just using that exponent rule you've been using all along. And that's going to give me a to the 3 minus 5, because our rule says when we are dividing, we subtract the exponents, and so we're going to get a to the negative 2. And that gives me a very important fact, that 1 over a squared is the same as a to the negative 2. And that gives us a meaning for our negative exponents. So when we see a negative in the exponent, we must understand that this negative simply means we've got 1 over a to the power of m. A negative in the exponent plays a very different role to a negative that's just a negative with a number. The negative in the exponent tells us we must go 1 over. Let's just make sure you've got this distinction clear. See if you can write the answer to each of these here. Pause the video and try it, and then we'll go over it together. Alright, so this one here, you notice that the negative is in the exponent. So it's just playing the role of telling you you must go 1 over 3 to the power of 1, which is just 1 over 3. Again, here, your negative is with the exponent. So it just plays the role of telling you you've got to go 1 over, and in this case it's 3 squared, which is 3 times 3, which is 9. Here, the negative is not in the exponent. The negative is playing a normal negative role. So what you do is you say 3 squared, which is 9, and then you've got negative 9. Let's have a look at another example on dividing and exponents. If we have to tackle something like this, remember we just go step by step, and first we work out what 15 divided by 3 is, and that is 5. We then move on to our x's, and we use our exponent rule, which tells us we go x to the 6 minus 2. We then move on to the y's, and we go y to the 3 minus 5. And so we get 5, x to the 4, And then here we've got 3 minus 5, which is negative 2. Now this is a perfectly decent answer, but in many cases they'll want us to write it all with positive exponents. And if they do want to make everything with positive exponents, we just need to remember what y to the power of minus 2 means. It means 1 over y squared. So 5x to the 4 y to the minus 2 is the same as 5x to the 4 over y squared. Let's look at the distributive law with division. When we're faced with something like this, and asked to simplify it, it's very tempting just to cancel the 3x with the 3x. But just like we saw, for example, when we had something like 5, x plus 2, that we had to distribute the 5 to both of the terms in the bracket, it's exactly the same here, that this 3x has to divide into the 12x squared and also into the 3x. So, to make it completely clear, I'm going to say this 12x squared needs to be divided by the 3x, and this 3x needs to be divided by the 3x. Doing this division is quite easy because we've been practicing this, right? We look at the numbers. 12 divided by 3 is 4, and x squared over x is just going to give you x. And this one, minus 3, we're subtracting, and then we have 3x over 3x, and that's just going to be 1. So our answer is 4x minus 1. One last thing I want to point out is that if we have a look at these two things, although they look quite similar, they're very different, because here you have a plus at the top. So you've got two separate terms, and this thing at the bottom needs to then be distributed to each of those terms. Whereas this one, just everything at the top is multiplied together, so it in fact can all be combined to be one single term, and so you don't need to use the distributive law for this one. Let me just go through each of them separately so that we see. So here you do need to distribute this to each of the terms at the top because you've got a plus, and it would also work if you had a minus. So we distribute this to each of the terms from the top, and then we do our division. 4 over 2 is 2, x squared over x squared is 1, y cubed over y squared is y, 6 over 2 is 3, x cubed over x squared is x, and y to the 6 over y squared is y to the 4. This one, in contrast, is very different because you've just got everything multiplied together at the top. So you don't have two separate terms that you need to distribute this into. So you're simply going to just go straight into the division. So 2 divides into 2 and into 4 it goes twice. X squared and x squared will cancel with each other, and this y squared we can cancel with this, just leaving one lot of y, and so what we will be left with there at the top is a 2 times a y times a 6 times the x cubed and the y to the 6th, and we can simplify that all down to be 12 x cubed and then y to the 7. So the important thing to note is if you've got a plus or a minus, you get two separate terms and you've got to distribute in. But if you've just got everything multiplied together, you don't have to do that.